Welcome to Kenya Ako Mathematics Classroom. Today I want to teach you polynomials. I want to teach about what you call factor theorem and what we call remainder theorem. I want to give you the general idea when we talk about factor theorem, remainder theorem. What do we mean by zeros of a polynomial? So in general, let me talk a little about polynomials. You see, a polynomial function in X is any function that can be expressed in the form a0 of x exponent n plus a1 x exponent n minus 1 plus a2 x exponent n minus 2, okay? And you have a n minus 1 x plus a0, okay? So any function that can be expressed in this form is what you call a polynomial function, and this one is in x, okay? So f of x equals a0 x exponent n plus a1 x exponent n minus 1 plus a2 x exponent n minus 2 plus an minus 1 x plus a0, where a0 is a constant. You see that the coefficient of the x exponent n term is a0, okay? That of x exponent n minus 1 term is a1. The coefficient here is a2, okay? In that order, then the coefficient here is an minus 1, then the constant is a0, okay? So the coefficient of the x exponent n term is a0, this one is a1, this one is a2. In that order, coefficient of the x term here is an minus 1, and the constant is a0, okay? So these are the coefficient of the variables and the constant. Some of them can be equal to 0. I want to give you the general idea. Now you look at this. If we have f of x equals, let's say you have 2x squared plus 5x minus 2. This is a quadratic function. It's a polynomial. Coefficient of the square term is 2. Coefficient of the x term is 5. And the constant is minus 2. So now what you need to understand is the highest exponent of the variable is what you call the degree of the polynomial. So because the highest exponent of x is 2, the degree of this function is 2. You have to take note of that. If you have f of x equals, let's say x cubed minus 2x squared minus x plus 2. This is a polynomial. Coefficient of the cube term is 1. Coefficient of the x squared term is minus 2. Coefficient of the x term is minus 1. And the constant is 2. This is a cubic polynomial. You need to understand that the highest exponent of the variable is 3. So the degree of this particular function is 3. The degree of this is what? Is 2, because that is the highest exponent of the variable. Now, if you have a function, let's say you have 2x plus 4. This is also a polynomial, only that we only have the x term. The coefficient is 1. So this, the degree of this is 1. The degree of this function is 3, because the highest exponent is 3. The degree of this function is 2, because the highest exponent is 2. So the highest degree, the highest exponent of the variable in the function determine the degree of that particular function. If the highest is 2, the degree of the function is 2. If the highest is 3, the degree of the function is 3. If the highest is 1, the degree of the function is 1. So in general, a polynomial function is any function that can be expressed in this form. Some of the coefficients can be 0, so take note of that. It's very important. Now, let me teach you something about what you call the factor theorem thing, okay? The factor theorem. So let's assume that we are given the polynomial, let's say f of x equals x cubed minus 2x squared minus x plus 2, okay? Yes, if this is the polynomial, the degree of this polynomial is 3, because the highest exponent of the variable is 3, so the degree of this is 3. Coefficient of the cube term, the x cube term is 1. Coefficient of the x squared term is minus 2. Coefficient of the x term is minus 1, and the constant is 2. So you can see that. Now, when we talk about factor theorem in general, what we are saying is we are talking about the factors of the polynomial function, okay? The factors of this polynomial function. Now, what is happening is this. If x plus a is a factor, okay? If x plus a is a factor of this particular polynomial, then it means that when you equate the x plus a to 0 and you make x the subject, the answer is minus a. Now, because this is a factor, it means that when you substitute x equals minus a in the function, that is f of minus a, because x is now minus a. So f of minus a means wherever you see x in the function, you have to represent that by minus a. So this should be minus a cubed minus 2 minus a squared minus, already you have minus a here, plus 2. When you solve for this and you are getting 0, when you solve for this you get 0. Why? Because the condition has been given that x plus a is a factor. So if x plus a is a factor of this polynomial, then it means that when you equate that factor to 0 and you solve for x and you take the x value you get back into the polynomial, you are supposed to get 0 as your answer. Take note, if after putting the x equals minus a into the polynomial we don't get 0 but we rather get a number, it means that it is not a factor. You need to understand that. It means that it is not a factor. Take note also, if x minus a is a factor, okay, of f of x, if x minus a is a factor of this polynomial, then it means that when you equate x minus a to 0 and you solve for x, you are getting what? A. So f of a means that wherever you see x in the function, you also represent that by a. So this, instead of s cubed, it will be a cubed. So we are going to have a cubed minus 2 a squared minus a plus 2. This must also give you 0. This must also give you 0 because you also give it the condition that x minus a is a factor. It's a factor. So in general, that's what we call the factor theorem. So take note of that. Now look at this. Look at this. So that's the idea behind factor theorem. That is the idea. Now, if when we divide f of x by x minus a and we are getting a remainder, that is, we are getting a value, then it means that when you equate the divisor to 0 and make x the sum, you are getting a. When you take a back here, we have what you call f of a. That means wherever you see x, you represent that by a. So we have a cubed minus 2 a squared minus a plus 2. This must give you that remainder, this one. Take note of that. So this time around, you are not getting 0 because when you divide the function by x minus a, you are getting a remainder. So when you equate the divisor to 0 and make x the subject, when you put it back into the function, you have to get the remainder. You will not get 0 because it is not a factor. If it's a factor, then it means that this will give us 0. But because we are getting a remainder, it's not a factor. So when we put the a back into the function, we will get a remainder. I will give a question and we are going to use the question to explain so that you understand what I'm talking about in general. So that you understand what I'm talking about in general. Now, okay, let's use this same polynomial. Let's assume that we are given the polynomial f of x, okay, is equal to x cubed minus 2x squared minus x plus 2. And we are asked to factorize, okay? When you are asked to factorize, it means that you have to find the factors of this polynomial. Find the factors. How do you find the factors of this polynomial? Look at the constants in the polynomial. The constant is 2. The factors of 2 will be 1 and 2. But we are going to use plus and minus, plus or minus the factors. So what we do is, first, we are going to use x equals 1. It means that wherever we see x in the function, we represent that by 1. So in doing that, we are going to have f of 1. That means wherever we see x, we put that, we put 1 there. Okay, so we have 1 cubed minus 2, 1 square minus 1 plus 2. Let's simplify. This is 1, 1 cubed is 1, 1 square is 1, 1 times 2, so we have 2 here, minus 1 plus 2. So 1 minus 2 is minus 1, minus 1 minus 1 is minus 2, and minus 2 plus 2 will give us what? 0. So now, because x equals 1, when we substitute 1 where we see x in the function has given us 0, then it means that x minus 1 is a factor. Yes, it's a factor. It means that x minus 1 is a, if you remember, I said something that if x minus a is a factor, then when you equate x minus a to 0 and make x the subject, when you put that a into the function, you're supposed to get 0. So you see that here we took x to be equal to 1. That's the first factor, the positive or the first factor of 2. And after substitution and calculation, we had 0. That means that x minus 1 is a factor of that polynomial. That means that if you take this value 1 to the left hand side, it becomes x minus 1. And it means that x minus 1 is a factor of this polynomial. So I guess you understand that. Now, because it's a cubic function, it means that the factors, we need to get 3 factors. Now we have gotten 1 factor. It means we have to test and see. Any one that will give us 0, then x minus that particular value that we substitute. is a factor, but we don't want to waste our time. What you are going to do is to divide this by this, okay? Yes, is to divide this by this and see what you are getting. The results will give us the other factor. So we are doing division of polynomials, okay? The divisor is x minus 1. The main function is s cubed minus 2x squared minus x plus 2. So let's start. This is how we do division of polynomials. S cubed divided by x will give us x squared according to indices. Then you multiply s squared by x, that will give us s cubed. S squared times minus 1 will give us minus x squared. You underline. We are going to subtract this from this, okay? So there is a minus here, but we don't write it. You need to understand that. So s cubed minus s cubed is gone. Then you have minus 2s squared minus minus. That will give us plus. So minus 2s squared plus s squared will give us minus x squared. Then what we have here, we have our minus x here. We drop the next term, minus x down. Then we start the process again. Minus x squared divided by x will give us what? Minus x. Then you multiply this by everything. Minus x times x give us minus x squared. Minus x times this will give us plus x. Then we subtract this from it. There's a minus here, but it's also, we don't write it. Okay, so we have minus x squared minus minus. That will be minus x squared plus s squared is off. Then what we have here, we have minus x minus. This will be plus x, so it's minus x because minus 1 times this plus 1 will give us minus 1. So minus x will give us minus what? 2x here. Then the last term is plus what? The last term we have here is plus what? Is plus 2. Then we divide minus 2x by x, and that will give us minus 2. Then we multiply minus 2 by x, and that will give us minus 2x. Minus 2 times minus 1 will give us plus 2. So we subtract this from this, and still the minus is here. So minus 2x minus minus 2x will give us 0, because this will tend to be plus. Then we have plus 2 here, so 2 minus minus 2, because that minus will cross out this to make it minus. So 2 minus 2 will give us 0. Then it means that when we divide this by this, we are getting this to be the answer, s squared minus x minus 2, and the remainder is 0. It means that this is also a factor. This is also a factor. Later, you can refer to my video on division of polynomials so that you can get the general concept. But in general, that's how we divide polynomials. Now, you see, when you get here, it means that when you divide this by this, you are getting this. So the factors in general, the first factor we had was what? X minus 1. So we have x minus 1. Then the next factor we have gotten is what we have at the top, okay? That is x squared minus x minus 2. X squared minus x minus 2. Now, this is x minus 1 is a factor. This is also a factor, but it's a quadratic factor. So we can simplify this. We can also simplify this. I hope it's clear. Now, let me get this off so that I will continue from here. Okay. So what we have now, let's solve the quadratic. We have x squared minus x, right? Minus 2. So let's solve this. Now, in solving this, you search for two numbers. When you multiply, you get minus 2. But when you add, you get minus 1. That's the coefficient of the x. You can refer to my tutorial on quadratic equation. You understand what I'm saying. So we have x squared. We have minus 2x plus x minus 2. Why? Because minus 2 plus 1 will give us minus 1. A minus 2 times 1 will give us minus 2. Now let's simplify. We factor x out. Because it's x squared, we have x minus 2 here. We factor 1 out, then we have x minus 2. So the first factor here is x plus 1. Look at the terms we have outside the bracket. And we maintain one of these because they are the same. That's x minus 2. So in general, the first factor was x minus 1. Now we have other two factors, x plus 1 and x minus 2. From here, from the quadratic equation, this is what we are getting. So these are the factors. So we will have to factorize. That means that these are the answers. These are the answers. Now take note, let me teach you this. When you are asked to find the zeros, when you have to find the zeros of the polynomial, it means that you have to equate x minus 1, x plus 1, x minus 2, all to 0 and solve. When you do that, then you solve for. When you do that, then you solve for the value of x. Take note, when you come here, what do you get? you have x minus 1, x plus 1, x minus 2 equal to 0. So when you equate x minus 1 to 0 and you solve for x, you get x equals 1. When you equate x plus 1 to 0 and solve for x, you get x equals minus 1. When you equate x minus 2 to 0 and solve for x, you get x equals 2. So you need to understand this. I hope it's clear. Now, okay, so let me get this off. I'm trying to explain what I'm talking about. So we have x minus 1, then we have x plus 1, then we have x minus 2. This is equal to 0. So when you equate x minus 1 to 0, x equals 1. When you equate x plus 1 to 0, x equals minus 1. When you equate x minus 2 to 0, x equals what? 2. So the zeros of the polynomial function is equal to, the first one is 1, second one is minus 1, and the next one is 2. These are what you call the zeros. These are what you call the zeros of the polynomial. So in general, this is the idea behind the factor theorem and the remainder theorem of polynomials. So take note, that's the general idea. If you have any question, ask your question in the comment section. I will explain further in my next